All right, we got our Unit 3 review on absolute value functions. So let's do this. The equation, okay, when this is changed to this. So remember, your formula is A, x minus h, where h is a lie. Okay, so if there's a negative a value, okay, that is a reflection across the x-axis. It flips over the x, okay? All right, what if there's a 3 in front? If your a value is 3, that's going to be a vertical stretch by 3, okay, a factor of 3. Okay, so inside of the bars we have a plus 5, outside the bars we have a minus 6. That's my h and my k. So remember that insiders lie. So when it says plus 5, that really means minus 5, and that it's horizontal. H is horizontal, so left and right. So if it's plus 5, that really means minus 5. So that means there's a shift left 5, and this minus 6 is vertical. That's down 6. Okay. Let's write the absolute value equation that matches the graph below and find the domain and range. So first things first, what's my a value? Okay, so if this is my vertex and this is the next point, rise 1 over 1, that's 1 over 1, okay, or just 1. My h value and my k value, so how much does it shift horizontally? So 1, 2, 3 to the right is h, 1, 2, 3, 4, 5, 6 is my k. So when I write my equation, I'm going to put y equals a, which is 1. Okay, but you don't need to write that 1 because 1 is implied. X, and sorry, that's supposed to be an absolute value bar. Remember, insiders lie. So if h is a positive 3, I'm going to put minus 3. And then k is 6, so plus 6. All right. The only thing that would be different is if a is something besides 1, you would put it right here in front of the bars. Okay. Domain. Okay, so it's from negative infinity to positive infinity. It's x because that's your domain. Or you could just put the all real numbers. That's fine. But for the range, the bottom y value is right here at 6. And it's less than or equal to, because it includes 6, y, and that goes up to infinity. Okay. Another way of writing these would have been interval notation, negative infinity, comma infinity, and then bracket 6, infinity. Either way, whether you do it with set notation with the inequalities or interval notation with the parentheses, either way. Okay, we want to sketch this graph. So I notice, first of all, that this has been reflected. Okay, so this is reflected. So I have to make sure that my graph goes downward. All right. So let's find h and k. K, remember, this is a lie. So instead of a positive 3, my h is negative 3. And my k value is 2. So let's put a point at negative 3, 2. And then my a value is negative, is just a negative sign, which means negative 1 over 1. That means it's going down 1, right 1, and down 1, left 1. Down 1, right 1, down 1, left 1. Okay, we get this absolute value that looks like this. So what are my x-intercepts? I got one right here at negative 5, 0. Don't just put negative 5, it's negative 5, 0. And then the other one right here at negative 1, 0. Now, whether you look at this graph or whether you graph this in the calculator, if you graph this in the calculator, you got to do menu 5-1 to get the trace to get these values, okay? Don't forget, you can do menu 5-1. Okay, my y-intercept I see right here is at -1, so that's 0, -1, because the y-intercept is when x is 0, x-intercept is when y is 0, okay? My vertex we already wrote off to the side is -3, 2, and it's at the top of a hill. That's a maximum, okay? Let's solve this absolute value function. When the bars are already equal to a number is when you can split it, okay? So I don't have any steps to do first. I just split it. 2x plus 3 equals +7, and 2x plus 3 equals -7. All right, so we subtract 3 on both sides. Oops. So 2x equals 4, and 2x equals -10. Your last step is to divide by 2 to get rid of that coefficient. So x equals 2, and x equals -5. Cool. And you could plot those on a number line if you needed to. On number 7, solving these. Now the bars are not by themselves, so first thing we need to do is get rid of the loner, -4. 10 minus 4 is 6. And then get rid of that 2, so we divide to get rid of that coefficient. Okay, so now I have absolute value of x minus 5 equals 6 over 2 is 3. All right, I'm running out of room here, so I'll just rewrite it over here. So that gives us x minus 5 equals 3, regular, and then x minus 5 equals -3. Okay, so we add 5 to both sides here. 3 plus 5 is 8. We add 5 to both sides here. -3 plus 5 is 2. All right. Cool. Solve the absolute value inequality, a little bit different. So when the bars are by themselves, that's fine. We're going to split this up. We're going to drop the bars. X minus 5 is less than or equal to, x minus 4 is less than or equal to 5. And x minus 4, and this is where the two changes happen. Greater than or equal to -5. This and this must change, right? The less than becomes a greater than, the positive becomes a negative, and now I can solve both of these. I can get rid of my loners by getting rid of a -4 by adding 4 to both sides. So x is less than or equal to 9. And then adding 4 to both sides, x is greater than or equal to -1. Okay. Now, this time it asks us to graph it on a number line. So the smaller number is -1, the greater number is 9. They're both underlined, so we're going to have shaded in circles. Okay, it's greater than -1, so it's going this away. It's less than 9, so it's going this away. So basically it's shading in between. Okay. Let's try another one. Let's get rid of this loner. We add 7 to both sides. So we get absolute value of x plus 3 is greater than 2 plus 7 is 9. Split that up. X plus 3 is greater than 9. X plus 3 is less than -9. Once again, these two things must change. Okay. And we just solve these by getting rid of the loner, -3 on both sides. X is greater than 6. X is less than negative 12. Now your number line, negative 12, positive 6. These are not underlined. These are going to be open circles. And then greater than 6 actually goes to the right, right? Less than negative 12, that goes to the left. So you see how sometimes they go away from each other and sometimes we have open circles? Very important. All right. Explain when an absolute value has no solution. An equation has no solution. When the absolute value bars equal a negative number. For example, if you had x plus 1 equals negative 2. That negative lets you know there is no solution, okay? All right. Now this is what we talked about yesterday with 3.5. So please remember, you put x minus, and then you have your goal or your ideal inside the bars equals, and then your variance, whatever it's going to change by. So ladies auditioning to join the New York Rockets must have a height of 68 inches, but this height can deviate, okay, variance or deviation, however you want to talk about that, up to 2 inches, okay? So think about it. I got my absolute value of x minus the goal, the ideal, is 68. That equals the deviation or the variance, which can be up to 2 inches. All right. So the best answer is going to be letter B. Now, number 2, write the equation that matches the following graph. There's 3 things I need to know before I can do this, okay? A, H, and K. So my A value, if I pick the vertex and then the next point on the grid, I'm going to count the rise over run, okay? So you're doing, again, rise over run for this. So it goes down 1, right 2. It's negative 1 over 2, okay? And then H and K, this point right here is 2, 3. So I got my vertex. So I can write my equation. Remember, the equation is ax minus h plus k. So y equals, my a we said over here is negative 1/2 x. H is a lie, the opposite of positive 2, so minus 2. And then my k value plus 3. All right, domain. All real numbers, or negative infinity to positive infinity, right? Because it goes forever to the left, forever to the right. But the range, okay, is going from bottom to top, negative infinity, all the way up to the top here, which is this y value of 3 bracket, okay? Or something like this. Okay, that's a negative infinity symbol. X-intercepts. So I see an X-intercept right here at negative 4, 0. And over here at positive 7, 0. Positive 9. Hold up. Positive 8, I should say. All right, so it's 8, 0. I guess 10 is supposed to be right here, because 10 does not go here. Anyways, the y-intercept right here is at 0, 2. My vertex we already got is 2, 3, and that's at the top of a hill, which is a maximum. Cool? All right. All right, and that's it. So that's your review, straightforward from our notes and our assignments. So make sure you finish your review, you turn it in tomorrow, and use it. Uh, please study in preparation for your test tomorrow, okay, for your Unit 3 test.